2.4, it says solving inequalities using addition and subtraction. Now, an inequality is a statement. It's like an equation, except it doesn't have an equal sign. Okay? It has these kinds of signs, the inequality signs. Let me write them up here for you. Okay? It could be the greater than sign. It could be the less than sign. It could be greater than or equal to. It could be less than or equal to. Okay? Those are the 4 inequalities. All right? So for instance, let's look at this first one down here, this little example. It says x is less than 3. Now we're used to x equaling 7 or x equaling -1. We're used to x equaling a number, right? But now x can be lots of numbers. Can you think of some numbers that I could plug in for x that are true? Great.
6. No, 1. Sorry.
1. Yeah, that works good. Allison? -6, yeah. Lou?
1.004.
Yes. How about 2.999? Is that okay? What about 3?
No.
No. Good. Good. Okay. So a solution of an inequality is any and all numbers that make the statement true. So think about this. You guys gave me a lot of answers that made that statement true, right? How many answers, how many numbers are there that would make that statement true? Bennett? It'd be infinite, right? They're all the decimals. We could keep going down on the negative side of the number line to negative infinity, right? So that's an infinite number of answers. Now, let's look at example. Well, you know what? I want to talk about, just before we do anything, I want to talk about this little example that they had for us up here. I'm going to bring it down under the example 1 and work on it there, and then just get rid of it when we want to do example 1. Okay? That says y plus 5 is less than or equal to y plus 5 is less than or equal to, was it -6?
Yes. Yeah.
-6. Okay. Now, we solve inequalities the exact same way that we solve equations. There's one exception, which I will tell you about tomorrow. Okay? It's when we're multiplying and dividing, but you don't have to worry about that now. It works exactly the same way as we solve equations. What would I do to solve this inequality, Cedar? Yeah. I do. So how do I get rid of the 5? I need to get the y by itself. I'm going to subtract 5 on both sides. Okay. And what do I have gray on the left side?
Y.
I've got y. And gray, what do I get on the right side? -11. So now the solutions, the things that work for y, are all the y's that are less than or equal to -11. Now we have to graph this. Let me show you how we graph it. This number is called the critical number. We put a dash in the middle of our number line, and we put that number right underneath it. Then we put a dash on either side. What number, raise your hand, do you think this one on the right is, Allison?
That would be 0, right?
You could make it 0, but that would make then this one over here -22. I'm going to make it -10. What does that make this one over here on the left, Luke? -12. Okay. Now, we put a circle around our critical number. Okay? And then we ask this question. Can -11 be the answer? Is it okay? Can -11 be the answer? It says y is less than or equal to -11. Is -11 a solution, Lily? It is. because it says it can equal negative 11. So I need to color in the circle because it can be negative 11. Okay? Can negative 12 be a solution, Casey? Yes. So I'm going to shade all the numbers in this direction. Can negative 10 be a solution, John? No. So I've shaded in the right direction. Does everybody agree with me? Everybody understand that? Can negative 12 be an answer?
Yes.
Can negative 6,000 be an answer?
Yes.
Can negative 11 be an answer?
Yes.
Can negative 11.00001 be an answer? No.
Oh, negative 11.
Oh, wait, I'm sorry, I made that mistake. No, you were right, negative 11.00001, because it's negative. I'm sorry, I was thinking wrong. Can negative 10.99999 be an answer?
Yes.
No, because it's over here, isn't it?
Yes.
Okay? All right. Now, let's look at this first example. All right? This first example says, the freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is a solid, ice. Write an inequality that gives the temperatures at which water is a solid, then graph the inequality. Casey, help me with this. Let's do the inequality. C is Celsius. What does it need to be? C is the degrees, right? We're going to let that stand for the temperature, okay? It can equal.
Or no, it wouldn't equal. It would be
less than or
Okay.
equal to. She's confused. Let me get rid of that. Okay. What do you think, Allison?
Negative 0. You gotta say 0 Celsius, right?
It's in there. How do I represent the temperatures where water freezes? Peyton?
Negative or 0 degrees Celsius and back.
And back. Okay, how do I write 0 degrees Celsius and back? Bennett?
C is equal to and less than 0 degrees Celsius.
Equal to and less than 0 degrees. 0 degrees. Can it be 0 degrees?
Yeah.
Yeah, because it says at temperatures at or below. That means less than or equal to. Okay? Now we need to graph this, and I need someone to talk me through this graph. Tell me what to do. Luke.
Okay, well, you should put you should put a mark in the middle.
Got it.
That's 0.
All right, that's 0. That's our critical number.
And you circle it,
Okay?
and then you shade that in because it can.
I'm not ready yet.
Okay.
I need
well, okay.
something on either
Then you
side.
put 1 on the right side and negative 1 on the left side.
Good.
Then you shade into 0.
It can be 0?
Yes.
0 is okay?
Mhm.
Okay, so I'm going to color it in.
And then it can't be 1.
No.
It can be negative 1.
Right.
So it's shaded across the middle.
Beautiful. Let's look at the next one. Okay. Now, this one says solve m plus 5 is greater than or equal to 10. John D., what do I do first? I do want to do that. What do I do first? Okay. Subtract 5. Where? From what? Uh-huh. Okay, good. Now, John D., what do I get on the left side? M. And on the right side? 5. Beautiful. Nicely done. Now, Catherine, help me graph this. What do I do?
In the middle.
Yep.
There's a mark in the middle.
Put a mark in the middle. Where do I go from there, McVee?
You put the 5 without more.
I put the critical number right under it, 5, okay? Caroline, I need you to sit. You can put that on my desk with the pass, okay? And now what do I do? Izzy?
Then you put
Where?
4.
Okay, 4 here.
And
6 over here. Now what? Put a circle over the critical number. I shade in front, okay. Are we happy?
No.
Lily?
No. Well, M can equal 5, so you have to
M can also be 5, so I have to shade in the circle too. I got to shade everything that the variable can be. Okay? It can be 5 and all this stuff over here. Okay? Any number. If I pick 6, 6 plus 5 is 11, and that's greater than or equal to 10. If I pick 6 trillion, that's 6 trillion plus 5. 6 trillion 5 is greater than or equal to 10. Okay? Anything in that direction solves that inequality.
That's awesome.
It is awesome. Let's look at the next one. Negative 10 is greater than x minus 12. Good. Cedar, what do I do?
Well, you need to get rid of 12, so that's 12.
Add 12 to both sides, and I'm going to get x, that sign, and 2. Okay. Who can read that to me? Raise your hand. Read it. Caroline?
2 is greater than x.
Okay. Read it the other way.
X is less than
Good. You have to be able to read it both ways because sometimes the x is on the other side. Now, help me graph this, Peyton.
2. Okay.
What's this?
1.
No.
2.
2. It's the critical number. The one in the middle is the critical number. I'm going to put a circle around it. What's this number?
3.
No. Number line. What comes here?
4.
No.
Oh, wait, we're going
Let's
back.
call it 1.
Yeah.
All right? And this
That's
3.
3.
Good.
Okay.
Now, let me ask you this, Lily. Can I color in the circle? Can it be
No.
2?
No.
It can't be 2. Where do I need to shade, Casey? To the left. But the arrow is pointing in the other direction. Doesn't matter. X is less than 2. You have to be able to read it both ways, right, Caroline? These are all the numbers that if I plug them in for X, they're less than 2. You got to think about it, okay? Let's look at this last one. Okay, you are competing in a triathlon, a sports competition with 3 events. There they are. Last year you finished the triathlon in 85 minutes. The table shows your times for this year's first 2 events. What possible times can you post in the running event and still beat last year's finishing time? Help me write an inequality that represents that information. Luke.
Let's say R.
R for
Greater-
running.
Greater than or equals.
Hmm?
Wait, no.
I don't like that. I don't like where we're going there. Allison?
I like to start with R. R would be the big deal. I think plus 17 plus 45.
Okay.
And they want it to be greater than or equal. Yeah. Or greater. But you wouldn't do less than. You want it to be bigger.
Why do you want your time to be longer?
Oh, you want it to be shorter because it's triathlon. Okay, so it would be less than or equal to.
Can it be equal to, Casey? We want to beat last year's time, not tie it.
Oh, so just be less than.
Do you see why? We don't want it to equal for 85 minutes, then we've tied our record. We want to beat it. It has to be less than 85. What do I do here? Now we're done. Great?
You graph it or
No, not yet. I got to solve it.
Oh, yeah. Well, add 17 45.
Yep, and that gives me R plus 62 is less than 85. Now what do I do?
Find out what
I do want to do that. McVie?
you would subtract 62 from 62 and 85.
All right, and R is less than 23 minutes. Oh,
Graph
it didn't say to graph it. We could, but it didn't say to. We just know that the running has to be less than 23 minutes. If it's 24 minutes, then we tie our record, right? We want to beat it. We don't want to tie it, we want to beat it.
It could be 23.
Great job, guys. You're ready.